So this is a question about trigonometric modelling. So we're told that the ship or the boat can only enter the port of Savannah when the water is deep enough, and the height or the depth of the water is modelled with the graph shown for us. So it starts with the time at midnight, and then it travels in hours, and we have the feet of how deep the water is. So we need to write down the period of the model first. Now the period of a model is the length of the wave. So if we have the maximum point up here, so we're told that the maximum point is at 6.25 and 57.5. So we're told that in the question just here. If we know this, then that means that half of the wave takes us up to 6.25, and then we have the other half of the wave to get back to that starting position. So the length of the wave, or the period of the wave, is 6.25 multiplied by 2. So 6.25 times 2, and that gives you a length of 12.5. Then we're told that the equation can be modelled in the form A cos bt plus D. And we need to work out what is the equation. So we're trying to work out what is A, what is B, and what is D. So D is always a good one to start with. D is our principal axis. It's the midpoint of the wave. So you are told that the wave starts at the coordinate 0 and 50.5. So we know that the difference between these points here are the 50.5 and the 57.5. So if we do 57.5 plus 50.5, and we divide that by 2 to find the average, that will then give us the principal axis, and the principal axis is 54. So 54 is where our wave oscillates up and down from. So we know that D is equal to 54. A is the amplitude, so this is how much the wave increases and decreases from that line, that principal axis. So on this one, you're going to do the 54 and the 57.5 and subtract them. And that will give you the amplitude, which is going to be 3.5. So if we know that it's moving up and down by 3.5, we then need to just think about what the picture of the wave looks like. Now, normally a cosine curve would start at the top of the graph, and it would go down and up and make a valley shape. This is doing the opposite because this one is a negative amplitude or a negative function. So it's actually negative 3.5. And then for the last part, B, this is the wavelength or the periodicity of the function. And for this one, you are going to do 360 divided by the length of our wave, which we said was 12.5. And that gives you 28.8. So we now have what we think is the function, and we can write that out in full. So WT is equal to negative 3.5. Let's just erase that part there. And that's cosine of 28.8t plus 54. So we think that that is then going to be our final function. Now what we can do here just to check is go to our calculator, and we can plot the function into our GDC. So negative, using this symbol here, 3.5 cosine, and then we think it's 28.8 x always put x in your calculator, plus 54. So we're expecting the window to go to 14 is what we have on our graph here for the x-axis, and then for the y-axis I'm just going to change that to -1, and it should be going up to around 60. And we can see there we have our function. Now we could change the window to what we see here, which is where the y-axis actually starts at 50. Or I might change mine to 48 just so I can see a little bit more of the graph. Okay, and it seems to be showing us the right thing. What we could just do to check it there is to find what is the maximum function, and the maximum value is 6.24, so rounded to 6.25, and then 57.5. So yes, that seems like we have the correct function, but it's always good to check on our calculator as well. Then part C, it says the depth of the water must be at least 53 for the cargo ship to enter the port. How many hours after midnight, which is when t equals 0, the first cargo ship can enter the point? So we're going to now add onto our graph the line of 53, which is this function here. So y is equal to 53. And we're going to add that onto our GDC as well. So 53. And then it can only enter the port when it is bigger than 53. So it can enter the port between here and here. It can enter the port on this section here. So we're now going to need to find what those intersections are. So we're going to look for the intersect. And let's find the one over on this side first. So we can see there that the intersect is 2.55. So 2.55. And that's at the value of 53. So that's that first coordinate. Now this question just says find how many hours after midnight the first cargo ship can enter. So the time is 2.55 and it's already written in terms of hours. So it's just 2.55 hours after midnight, which means that essentially it would be 2.55 because it asks for it in hours after midnight. And then it says, hence determine the total number of hours between midnight and midday the following time when they can enter the port. So this is where you want the whole section that we have shaded in yellow here. So all of that time there is where they can enter. And we're going to need to find the intersections at both of those 2 points. So we've got the first intersection. We're now going to look through to find the second intersection, which is on the other side of this curve. And we can see that is 9.95. So we have 2.55 hours up to 9.95 hours. So between the two, we're going to subtract them. We have 9.95 minus 2.55, and that gives us 7.4. So for 7.4 hours of the day, the cargo ships can enter the port because the waves or the height of the water is deep enough that they can then fit in. In terms of the marks for this question, the first one is 1 mark, and that's just for the answer there of 12.5. For the next part, the answer for the values of A, B, and D, there are 1 mark available for the answer to D, so to find that principal axis. There for the amplitude, there is a mark available there for recognizing that it's negative, so that's for the negative, and for the value of 3.5. And then for the B value, there is a mark for doing the method of dividing 360 by the period, and there is also an answer mark for the 28.8. For part C, this is 2 marks. One is for some sort of method mark. Now you could have written the coordinate, or you could also have annotated on the graph and found this coordinate or drawn this line on. Any of those would be fine for the method mark. And then there is 1 mark for the answer of recognizing that it is 2.55 hours. And then the last one is also a method mark for using the 2 values or intersections, and then 1 for the answer where you've subtracted them together and you found the 7.4.